Today we start chapter number 5 from the syllabus of 11th standard, and it is gravitation. So in introduction, all material objects have natural tendency to get attracted towards the earth. It is because of gravitation. All bodies are attracted towards the earth with constant acceleration, and that acceleration is called as acceleration due to gravity, and its value we are taking generally 9.8 meter per second square, and it is the average value of acceleration due to gravity on equator and pole. And this fact is first time recognized by Galileo. Every massive object in universe experiences gravitational force. The gravitational force is a mutual attraction between any two objects because of their masses. Gravitational force is always attraction force, and its range is infinity, that we already covered in the previous chapter. It does not depend on the intervening medium. These are the properties of the gravitational force which we already learned. It is weaker than the fundamental forces. Gravitational force is weaker than electromagnetic, weaker than strong nuclear, as well as it is weaker than weak nuclear force. Kepler's law. Now we start Kepler's first law, and this law is also called as law of orbit because it is related to the orbit. And the law states that all planets move in elliptical orbit around the sun, with the sun at one of foci of ellipse. This is Kepler's first law, and it gives an idea about the orbit of the planet, so it is also called as law of orbit. Now we start Kepler's second law. It is also called as law of areas. Now what is law of area? Now you know that planet is revolving around the sun in an elliptical orbit. Now at any time instant, we consider sun is at this point, at point 1. In time t, sun moves to this position, position 2. Now this line joining sun to planet, this line after time t shifted to new position, and this line covers that much area. This line sweeps that much area. Any other time, the sun, this planet, sorry, not sun, planet is at third position. In same time t, it moves to the position 4. The planet moves to position 4. Now here, the line joining sun to that planet, it changed its position in time t, and the area covered by that line is this. If both the times are same, then areas are same. So here you can see here A is equal to B. So area A and area B both are same. So we can write here, line joining sun to planet sweeps equal area in equal interval of time. And this is law of areas. In another word, the same law we can write like this way also. Aerial velocity of planet is always constant. Aerial velocity of planet is always constant. The meaning of this sentence is same as above. Now we consider that a planet is revolving around the sun in an elliptical orbit. The law of areas can be understood as the outcome of conservation of angular momentum. So the reason behind this law of areas is conservation of angular momentum, which we have to learn later. The area swept by planet of mass m in given time interval delta t is, so time interval is delta t. In that delta t, area swept by planet we have to write. So area is equal to half r bar cross this distance, and it is v into delta t. We consider this distance is a straight line and this is a triangle. If this is a triangle, you know that area of triangle is half base into height. So here this is r bar, and this distance we can write here v bar into delta t. You know that v bar is equal to this delta x by delta t. So distance delta x is equal to v into delta t. So that we use this distance is equal to v into delta t. Now here we divide both the side by delta t. So we get delta a by delta t is equal to 1 by 2 r bar cross v bar. This delta t and delta t get cancelled, so only v bar here. Now after that we know the momentum. Linear momentum is given by formula m into v bar. So by using that we get v bar is equal to p bar divided by m. So let me substitute here. Delta a by delta t is equal to 1 by 2 r bar cross p bar divided by m. So instead of v bar we are written this. But here angular momentum we get by this formula. This formula we already discussed in the mathematical method also. Angular momentum is r bar cross p bar. Now here we can write r bar cross p bar is equal to this angular momentum L bar. Hence we get delta A by delta t is equal to L bar upon 2m. So L is the angular momentum. I told you it is second law is related to conservation of angular momentum. Conservation means angular momentum is constant. Means L is constant and mass of the planet is also constant. Constant divided by constant is a constant. So here we are written delta A by delta t is equal to constant. And this is a law of areas. I told you this same law we can write in another format, areal velocity. This delta A by delta is areal velocity. Hence we can write areal velocity of planet is always constant, and this is Kepler's second law. Next article is Kepler's third law. The mathematical statement of Kepler's third law is t square proportional to r cube. In this formula where t is period of revolution of planet around sun, and r is a semi major axis. You know that major axis is what? So I told you this is a major axis, a larger axis. Half of that is a semi major axis. So r is semi major axis of ellipse. Then you can remember this statement, t square means square of t means period of revolution is directly proportional to cube of r means semi major axis of elliptical path. So if you remember this mathematical equation, you can remember law of period. Now this is example 5.1. It is a solved example. What will be average duration of year if distance between sun and earth become thrice the present distance? If we made the distance thrice, then obviously distance is increased, then period is also increased. It is greater than 365 days. Now initial period is 365 days. So R1 is the present distance we consider. R2 is what? It is thrice. So R2 is thrice R1. Then by Kepler's law, t square proportional to r cube, that you know. By using that, you can write a formula. You can write formula here. T square divided by, this is the basic formula, and by that we can write T2 square divided by T1 square is equal to constant multiplied by R2 cube divided by constant multiplied by R1 cube. This constant get cancelled and we get this formula. T2 by T1 bracket square also we can write is equal to R2 by R1 bracket cube also you can write, or you can write individual cube here. Okay. Then taking square root of both the side. By taking square root we get T2 by T1 is equal to R2 by R1 raised to 3 by 2. Then we substitute R2. R2 is how much? Thrice R1. So R1 get cancelled. So 3 raised to 3 by 2. So that you can write like this way also. 3 multiplied by 3 multiplied by 3 raised to cube and raised to 1 by 2. Sorry, 3 cube means 3 multiplied by 3 multiplied by 3 raised to 1 by 2. So it means that 27 raised to 1 by 2, root of 27. So here we are written T2 by T1 is equal to root 27. So we have to find out T2. So T2 is T1 into root 27. T1 is 365 multiplied by root 27. After solving this, we get it is 1897 days. 1897 days is the period when distance is thrice the present distance. Similarly, when the distance is twice the present distance, we get a period of revolution of Earth around the Sun is 1032 days. Only here thrice R1 is there. Here we substitute twice R1.